గుడ్ ఈవినింగ్ చిల్డ్రన్, బాగున్నారా అందరూ? ఈరోజు ట్యూస్డే కదా. ఈ సంవత్సరంలో, కొత్త సంవత్సరంలో జనవరి మంత్లో సెకండ్ ట్యూస్డే మీ ముందుకి మంచి సెషన్ తీసుకొని రావడం జరిగింది. ఎలక్ట్రానిక్ కాంపోనెంట్స్, ఇవి లేకుంటే ఏ వస్తువు కూడా తయారు కాదు, అవన్నీ మీకు తెలుసు. ఈ ఎలక్ట్రానిక్ కాంపోనెంట్స్ ప్రాజెక్ట్స్లో ఎట్లా యూజ్ చేస్తారు, ఇవన్నీ తెలపడానికి మనకి విజ్ఞాన ఆశ్రమం నుంచి కిషోర్ గారు వచ్చారు, అలాగే శ్రీనివాస్ గారు వచ్చారు. సో వారు లైవ్లో మీకు సెషన్స్ వివరిస్తారు. ప్లీజ్ ఓవర్ టు యూ కిషోర్ జీ.
Thank you very much, Sudarshan sir and Ismail sir. So good afternoon, everyone. In today's session, as Sudarshan sir said, we are going to go through basics of some of the electronic components. There are so many different types of components. However, we will learn about 4 of them and how they are used in one particular project. Specifically, their function and why they are used in this project. That is more important for us to learn. So let me begin sharing my screen. Hello everyone. In today's session, we are going to learn basics of some of the electronic components, and we are going to also build some project. We are going to learn about these components through projects. It is not going to be only some theory about those components, but how these components are used in the projects is what we are going to learn in today's session. So for that, what we are going to do is we are going to build a solar desk lamp through which we will learn some basics of the electronic components used in that project. So this is the circuit diagram of the solar desk lamp, in wherein we have used the LED, a transistor, a resistor, a diode, and solar panel. Along with that, we are going to also use the chargeable battery. We will learn about each of these components in detail now. So the first one is solar panel. So how these solar panels work? So basically they are P and N type junctions. So there are P type silicon wafer and N type silicon wafer. As the sunlight falls on the solar panel, what happens is the electrons they keep on flowing, and the negative charge, basically the electrons flow through the circuit, and that is how the bulb or the LED is switched on. So that is how they get the power, and this is how solar panels work. The next component is as a resistor. All of you have used the resistor in your projects. So resistance is nothing but opposition, any substance offered to the flow of electric current. So it is denoted by uppercase letter R. It is measured in ohms. It doesn't have polarity like positive or negative terminal. You can use either of these ends as a positive or negative. So as this picture you can see, the formula are given by Ohm's law. We'll learn more about Ohm's law in further slides. But you can see this by this picture. Resistance, how this voltage is having resistance for the flow of electrons as current. So this slide, you can see that resistors are basically color coded. 10 ohm resistor, and the unit of the resistor resistance is ohm. So how do we measure the value of resistance? So some of the resistors are 5 band or 4 band colors. We will see significance of these 5 bands or 4 bands. Like for example, in this 4 band resistor, the first 2 stripes are represent digit. The third one from the left denotes multiplier, and the last stripe denotes the tolerance. For example, in this particular resistor, as you can see, the first stripe from the left is brown color, and the digit, as you can see, the table is 1. So stripe number 1, color brown, so that denotes digit 1 in this particular resistor. As we go to the next stripe, the black stripe, what it denotes, stripe number 2, the color is black, so the digit that this particular band denotes is 0. So the second digit from the left is 0. So 1 and 0 so far. Now we'll go to the third stripe. Actually this is a 4 band resistor, so we are not going to consider stripe number 3. So this brown color from the left, third left, is a multiplier. So brown color denotes multiplier 10. So 10 into 10, which is nothing but 100, and unit of unit of resistor is ohm. So the value of the resistance is 100 ohm. The last band is golden color, which is nothing but a tolerance. So which is a value 5%. So 5% tolerance on 100 ohm. So 5% of 10 is like 5. So 95 to 105 ohm. So the value of this resistor varies from 95 to 105 ohm. Let's measure the actual value of resistance of 100 ohm resistor using multiplier, using multimeter. So which comes around 92, which falls between 95 to 105 ohms. So the 5 band resistor, same as that of 4 band resistor. The first stripe from the left is orange, stripe number 1, which is digit 3. Second stripe also denotes brown color, orange color. The digit is 3. The third stripe denotes black, 0. And the fourth one, black, multiplier, if you can see, as 1. So 330 into 1, that becomes 330 ohm, and tolerance is 1%. So value varies from 337 ohm to 333 ohm. Let's measure the actual resistance value of 330 ohm using multimeter. So it shows 329.9, so close to 330 ohm is the value of this particular resistor. We can connect the resistors into our circuits either in series, like they are joined one after another, or parallel. That is, like you can see them in the picture here, that they are joined connected in parallel. And you can also make a combination of parallel and series. Now let's see resistors when connected in series. So R1, R2, R3. So total resistance of resistors connected in series, that is RT, is sum of all these resistors, R1 plus R2 plus R3. Now in this case, there is only one resistor of 10 ohm. So the total resistance value of the circuit is 10 ohm, because there is one resistor. When we connect another resistor of 5 ohm, 10 plus 5 becomes 15 ohm. So the total resistance is 15 ohm. Now we are going to connect one more resistor. So 10 plus 5 plus 5, the total resistance value becomes 20 ohm of this circuit. Now let's verify this using Tinkercad. So go to the next circuit, create new circuit, and just give it a name, resistance in series. I'm just refreshing it. Now I've taken one resistor of 10 ohm. I'm going to take a multimeter, and I'm going to select resistance as a mode for multimeter, because you can check voltage, you can check current. So another resistor of 5 ohm. I'm going to connect these both resistors in series. I'm using the standard colors, red and black, for positive and negative terminal. So I'm going to simulate. So 10 plus 5, the total resistance value is 15 ohm. Now I'm going to add another resistor of 5 ohm. I'm going to connect that again in the series. So 10 plus 5 plus 5. I'm verifying that 10 plus 5 plus 5 becomes 20 ohm. Now resistors in parallel circuit. So when they are connected in parallel, basically, it reduces the total value of resistance. If we place them in parallel, for example, in this case, basically the formula of the total resistance is 1 divided by 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4, provided we have connected 4 resistors parallelly. They can be represented in other ways also, like 1 upon RT is equal to 1 upon R1 plus, so sum of basically inverse of all resistors. So they may look difficult. In this case, we have connected 10 ohm plus 10, another 10 ohm and 10 ohm, 3 resistors of 10 ohm in parallel. So the total value of resistance is 1 upon 1 divided by 1 upon 10 plus 1 upon 10 plus 1 upon 10, which becomes 1 upon 0.1 plus 0.1 plus 0.1, that is 1 upon 0.3, that is 3.33 ohm. Let us verify this using Tinkercad circuit. Now I'm going to give it a name, resistors in parallel. I'm going to take one resistor of 10 ohm. I'm going to use copy feature now, because I'm going to use same 10 ohm resistors 3 times. And I'm taking a multimeter, another same thing. We are going to select resistance mode, connect them in all positive terminals of 3 resistors, and then negative terminal of all resistors. So this becomes parallel circuit. Once I make the circuit, after simulation it says 3.33 ohm. Now there is a trick. So for example, if you want to use 200 ohm resistor, but you don't have them in your lab, and if you have 100 and 100 ohm, simply you put them in series. Or if you have two resistors of 50 ohm and one of 100, what you will do is 50 plus 50 plus 100. So you will put them in series instead of saying that we don't have 200 ohm resistor and we can't make a circuit. So that's a trick. So basically, we are going to learn the Ohm's law. So this was derived by German physicist George Ohm. He derived this Ohm's law to represent the relationship of voltage, current, and resistance. So since this picture denotes that if we know what is the voltage or current, we can derive what is the resistance. Or if we know two of these values, we can derive the third value. So for example, these are the three formulas used in Ohm's law. So voltage is equal to current multiplied by resistance, or current is equal to voltage divided by resistance, and resistance is equal to voltage divided by current. If you see this, oh, you might be worried. Oh, I need to remember all these formula? You might be worried about it, but no worry. If you just remember this Ohm's law triangle, V divided by I, V I R, put into this particular format of triangle. So what we are going to do is, say for example, if you want to find out the voltage, the resistance is 3 ohm and voltage of the battery. Provided that we need to know what is the current. Say for example, the current is 2 amperes into the circuit and the resistance is 3 ohm. So we know I and R. We want to find out the value of voltage. So what we are going to do is, if you want to find out the value of V, so what does this triangle represent? V is equal to I into R. So this is nothing but voltage is equal to I, that is 2 ampere multiplied by 3 ohm. So the total value of the voltage is 6 volt in this particular case. Now we'll find out the relationship between voltage and current. For that, we are going to add another battery in series. So 6 plus 6 volt, when batteries are put into series, they add. So 6 plus 6 volt, 12 volt. So now we are having 12 volt and the resistor is of 3 ohm, the same thing. So 12 volt divided by 3 ohm, the current is 4 ampere. Now we have added two more. So total batteries of 6 volt. So the total voltage is 24 volt. So divided by 3 ohm. So the current flowing through the circuit is 8 amperes. So what is the relationship of voltage and current? V is equal to IR. So that relationship is current is directly proportional to the voltage. Double the voltage, double the current. So as you increase the voltage, the current will increase. And see, for example, higher the voltage, brighter will be the bulb. So 1.5 volt, the bulb is not that bright as compared to when the voltage is 9 volt. So that is much brighter. Now in the second case, how do we find current when we have the value of voltage and resistor? Now in this case, for example, using the same triangle. So what we are going to do is, since we want to find I, so I is equal to V divided by R. So 6 volt divided by 3 ohm, which is nothing but 2 amperes. So the current flowing through this circuit is 2 amperes. So in next case, what we are doing is, we have added another bulb in series of 3 ohm resistance. So when resistors put in series, they add up. So 6 volt divided by 6 ohm, the current is 1 ampere. So two more bulbs of 3 ohm. So total resistance is 3 plus 3 plus 3 plus 3, that is 12 ohm. So the current is 6 volt divided by 12 ohm is 0.5 amperes. So what is the relationship of current and resistance here in this case? So current is inversely proportional to the resistance. Double the resistance, half the current. So if you want to have more value of current into the circuit, you will reduce the resistance. If you want to increase or if you want to decrease the value of current into the circuit, you will add the resistance. So current and resistance, they are inversely proportional. So we are going to see that. So lesser the resistance, more the current. Now in this third case, we have values of voltage and current. We want to find out what is the value of resistance. So same thing, R, we want to find out R. So R is nothing but V divided by I. That is voltage divided by current. So in this case, the voltage is 12 volt, 6 plus 6. That is batteries are put in series. So voltage divided by current, that is 12 volt divided by current is 0.5 ampere. So the total value of resistance is 24 ohm. Now we are going to verify the Ohm's law using LED and battery. So the Ohm's law is important for you to calculate, values of either current or voltage or resistance, provided you know two of the values. If you have value of voltage and resistance, you can find out current. Similarly, if you have value of resistance and current, you can find out value of voltage. Now, using this three different LED circuits, we have used three different resistors: 100 ohm, 450 ohm, and 900 ohm. Let's see what happens. Three cases. First case, we have used 100 ohm resistor. So the value of current is 9 by 100, that is 0.09 ampere, which is 90 milliampere, which is too much for the LED, which will get burned. In second case, the resistance is 450 ohm. So the value of current is 20 milliampere, which is okay for LED to bear that much current. In third case, the value of resistance is 900 ohm. So the value of current is 9 by 900 ohm, which is 0.01 ampere, 10 milliampere, which is too low. The LED will not glow. So we'll verify that current is 0.5 ampere. So the value of Tinkercad, which will get burned. In second case, the resistance is 450 ohm. So the value of current is 20 milliampere, which is okay for LED to bear that much current. In third case, the value of resistance is 900 ohm. So the value of current is 9 by 900 ohm, which is 0.01 ampere, 10 milliampere, which is too low. So you can see that 100 ohm resistance is too low. So what will happen is 9 by 100. So it will be like 0.09 ampere, that is 90 milliampere. So it is too much of current into LED. So this LED will just simply burn. So if you add a resistance of 450 ohm, the current reduces. So since we have increased the resistance, the current will reduce. So it will reduce to 20 milliamperes. 9 by 450 is 0.02 ampere, that is 28 milliampere. So LEDs, typically 5 mm LEDs, they can bear this current of 0.02 ampere, that is 20 milliampere. But if you keep on increasing the values of resistance further from 450 to 900, current will further reduce, but LED will not that much bright. It will keep on dimming. The LED will not glow. So we'll verify that using Tinkercad. So we'll give it a name of this circuit, Ohm's law using LED. So I'm going to take a 9-volt battery and one LED, and I'm going to connect it. So there is no resistor here. In this case, I'm using. We'll see that without resistor, the voltage is 9 volt. And if I say simulate, the bulb will burn. Now I'm going to take another resistor, which is of 50 ohm. I'm going to again connect 50 ohm resistance. So it shows that LED is having 121 milliampere. Now when I add a resistor of 100 ohm, so the current is showing 65 milliampere, which is again too much. So better I put a resistor of 450 ohm, the LED will work properly. So as I keep on increasing the value of resistance, the LED will dim. I mean, it will not be that much bright. It will keep on dimming further. Now we are going to learn more about diode. So what are diodes? So diode is basically, it is a device which allows current to flow only in one direction. It has a polarity, unlike resistor. It has a positive and negative pole. There is one fine line drawn. There's a white line near the cathode terminal. The diodes protect our devices on the circuit from reverse polarity. If you connect it accidentally other way, they will protect. So basically this is the structure. It has two leads, body, and one white stripe that is at the one end. So the terminal, that the end that has a white line, is a cathode, and the other terminal, which you can see on the left side, is anode. So positive and negative terminal of diode. So there are different types. The Zener diode, or LED itself is a diode. This is just for your reference. I'm not going to go much into details. So diodes work like a valve. So you can see that there is a valve here. Water flows from left to right because the valve can open. So it can the water can flow from left to right. But when the valve gets closed, the water cannot go back from right to left. So the valve gets closed. So similarly, the diodes protect from the reverse current. So in this case, the LED on the top is working properly because the diode is connected appropriately. If we put the diode other way, it will protect, it will not allow the current to flow. So that in this case, the LED will not glow. So the diode, this white line has to be connected to negative terminal. So only in this case, it will allow the current to flow. So if you connect this white line to positive, it will stop the flow of the current. So it simply works as a one-way wall. So it will stop the flow of current in opposite direction. So if you accidentally connect any component in reverse polarity, so what will happen? That component will burn. So if you add a diode to the circuit, it will not allow the reverse current. So it will protect those components. We will verify that using Tinkercad. So let's verify this using Tinkercad. In first case, the LED is working properly because there is a resistor of value 450 ohm. So what I'm going to do now is I'm going to remove these connections and I'm going to change the polarity of the battery. You can see that I've switched it. Now I'm going to connect the positive terminal of battery to the negative terminal of LED and vice versa. And when I simulate, the LED will just burn. So what I need to do is, so when I connect the diode in this case, so accidentally even if I connect the batteries reverse, positive to negative and negative to positive, the diode will not allow the current to flow through that line, but it will allow the current to flow through it, and the LED will not get damaged. So now you will see I've connected the diode above. When I simulate, the current will flow through the diode but not through the LED. So what it has done is, when you connect the diode, so diode has to connect, this white line has to be connected to negative, but we have connected the LED reverse. So we have connected positive of LED to negative. So if we don't have diode, it will simply burn. But in this case, we have diode. So what will it do is, it will not allow the current to flow through this, but it will simply pull the current to pass through it. So it will protect the LED through that line, but it will allow the current to flow through it, and the LED will not get damaged. So now you will see I've connected the diode above. When I simulate, the current will flow through the diode but not through the LED. So it will protect the LED. Now I'm going to again reverse the polarity, positive to positive and negative to negative, and I'm going to use diode again in the circuit, and the connections are proper. When I say simulate, what will happen is the LED will glow. So this is how diodes protect the circuit. So now another component that we are going to learn here is transistor. So transistor is basically a type of semiconductor which has both conductive and insulating property. It can be used as a switch or an amplifier. It is basically used to control or regulate the flow of electronic signal or electric current. So most of the transistors have this structure. So one end is flat edge, the flat surface. The another edge is round edge. There are three terminals. One is collector, the middle one is base, and emitter. So this is a typical structure of NPN transistors. All the transistors are of not same structure. Then there are different types of transistors, as you can see in this picture. We are not going to go much into details of this, but the main two types of transistors are bipolar transistor and field effect. So we are going to use bipolar transistors. So as I said earlier, they can be used as a switch, to switch the circuits on and off or amplify the signal. So as in this case, you can see the symbol on the left side. So the current flows from C, that is collector, to emitter, and the base is used to trigger the current flow from collector to emitter, that is C to E. We will see this in detail in further slides or further in part of the video. So how does the switch work? When there is no switch, the bulb continuously turns on. So when there is a switch, one can make the bulb on and off, but it needs some manual control. So somebody needs to put the switch on or off. How can we then automate this? We can automate this process of switching on and off using a transistor. So as you can see that we have added a transistor instead of a switch or as a switch. So transistor blocks the current right now. So the current light is off. So what happens is, so when there is a flow from collector to emitter terminal, So the base needs to have some minimum triggering current. Only then the current will flow. So in this case, so this is a collector. This pin is a collector pin. This pin is emitter. So this line or this terminal will collect the electron flow, and only when the base gets some voltage, external voltage, only then this will open. Otherwise, this flow is closed. So we need to have some external, voltage provision to the base, that this pin. So if we switch this on, only then this line will switch on. So this becomes automatic switching on and off. So we will see, if you don't understand this, we have made it little simpler by using some comparison it with some water flow. We will see that. For example, here in this case, a battery is added next to the transistor base. So when there is a small voltage passed through the battery to the base, then the transistor will turn on. Only then the current will flow from the collector to base. So we'll take some example of pipe. So imagine there is a continuous flow of water from the pipe, as that of continuous flow of electrons on the right hand side picture. So there is no switch. So water is also flowing. Similarly, the current is also flowing. So if you want to cut the water, what will you do is you will put a disc. Similarly, if you want to cut the electrical flow, you will add a switch. So switch works as a disk. So in this case, somebody has to manually put the switch on and off. So we have added a swing gate, then the current will flow. For example, here in this case, a battery is added next to the transistor base. So when there is a small voltage passed through the battery to the base, then the transistor will turn on. Only then the current will flow from the collector to base. So we'll take some example of pipe. So imagine there is a continuous flow of water from the pipe, as that of continuous flow of electrons on the right hand side picture. So there is no switch. So water is also flowing. Similarly, the current is also flowing. So if you want to cut the water, what will you do is you will put a disc. Similarly, if you want to cut the electrical flow, you will add a switch. So switch works as a disk. So in this case, somebody has to manually put the switch on and off. So we have added a swing gate onto the water pipe. So what does this swing gate will do is it will switch the water flow on and off, just like the switch in the electrical. So in electrical connections, electronic connections, this switch, one has to manually put it on and off. Only then the current will either flow or it will stop. Similarly, in this plumbing case, only when there is some gate, some valve, only when someone operates this valve, this disc, this pipe will get closed or open. So we have to have some mechanism to automate this. Similarly, like this button. So like how this transistor will work as a switch, we are referring this as an example. Circuit. So I'm just using this water pipe example as analogy. So the flow of water is controlled by the swing gate. So further the swing gate opens, the more water is allowed to flow. So the swing gate is helping the water to flow or not. So it is closing the disc or opening the disc. So right now there is not enough water to open the gate. So when there is minimum water through that pipe, the swing gate will open the disc and the water will flow. So likewise, it needs a minimum current through that base. Only then the current will flow from C to E into the transistor. So in pipe case, there is minimum water required. So when there is a minimum water that push this swing gate, it will open this disc so that water will flow from here to here. So likewise in electronic connections in transistor, the base needs to have minimum value of current. So this resistor, basically it needs to have minimum current. Only then current will flow from C to E, that is collector pin to emitter pin. So it works exactly like this pipe mechanism. This is for just your understanding. Collector to emitter. So this base acts as a that gate into the water pipe. So for example, when there is a maximum flow because of the movement of the swing gate, the water will flow. So this analogy is applicable to the NPN transistor. So in this case, you can see the circuit diagram. When there is a minimum triggering current to the base, current will flow from collector to emitter. So the circuit will work. So now let's draw a solar lamp circuit in Tinkercad. So I'll go create a new circuit. What I need is a solar panel of 6 volt rating and 100 milliampere current. Then I'm going to take one LED. I'm going to need a 100 kilo ohm resistor and a transistor, NPN transistor, and a diode. So what I'm going to do is I am also going to need two batteries and battery holder with on and off button. So I'm going to connect all these components together. So first thing is I'm going to place the components as required. Connect the positive terminal of battery to the positive terminal of LED and solar panel. I'm going to connect negative terminal of solar panel to the diode. Make sure that the line on the diode, that white line, is towards the negative terminal, that is cathode. I'm going to also connect 10K ohm resistor through negative terminal, and the resistor is connected to the base, that is middle terminal of transistor, and emitter terminal of transistor is connected to diode. And now on top of diode I have connected the negative terminal of battery. The collector terminal of transistor is connected to the LED. Now when I turn the simulation on, as I put the solar light, sunlight, the LED will switch off. As I bring the solar panel inside, or this circuit inside under the shadow, the LED will glow. This is how the LED will glow on into the shade, and into the sun it will turn off. And the battery holder switch you can use to switch the LED on and off when you don't need the light to turn on in the night. So this is how. So basically, when you put this solar lamp into the sun for charging, this LED will switch off automatically. When you take this inside, in the dark, in the night, the LED will automatically turn on. But you don't want to turn this LED on, always. So that's why this external switch is needed. How the circuit works, you can also, export the circuit diagram from Tinkercad, and also you can export the parts required. So I have exported and downloaded the circuit diagram, and also exported the bill of material, what components are needed for this circuit. You can also export the circuit diagram image as a PNG file. So this is how the circuit works. So on the top, so on the left side, there is a circuit. On the right hand side, we have seen that how transistors work. So basically, when there is a minimum triggering current through that resistor to the base, only then current will flow from collector to emitter. Now, as you can see, that transistor blocks the current, so the light is off. So it acts as a switch. When there is no triggering current to the base, that is middle pin, the current will not flow. We have seen this example of the pipe. So when the swing gate opens, only then the water will flow from the main pipe. So it needs to have some minimum triggering current. So we will now see, what is the function of transistor into this circuit. So as you can see on the figure on the right hand side, so this resistor is connected. So when you put this lamp into the sun, there is a maximum resistance to the base. So there is no minimum current. So the transistor is switched off. So the LED will switch off into the sun. When you bring the solar lamp into the shadow or dark, the resistor value is minimum, so it will have some maximum current to the base, so the circuit will complete and the LED will turn on. So the main purpose is, when it is getting charged, the LED should be off, so this bulb should be off. So what does that mean is, there should not be a current flowing from C to E. So what we need to do is, to close this current flow, we should close this current also. So to have the least current or no current, we have learned that the resistance value should be more. So actually, when you keep this solar panel into the sun, the value of this resistance is more. So no current into this terminal. Obviously, this is disconnected. So LED is switched off into the sun. If you put this into the light, when you get this lamp into the shadow or dark, what will happen is there is a least current, a least resistance. So least resistance means more current. So the base will get more current and this line will also open. That means the LED will turn on. So you will, in the night, this LED will turn on automatically, provided that this battery is also charged. This solar panel helps in getting this rechargeable battery charged. So that's the function of a transistor into this circuit. So because of transistor, the lamp will turn only in the dark, and when you take it into the sun, the light will switch off. So now what is the function of diode? As you can see, diode protects the circuit from reverse polarity. It will not allow the current to flow in the reverse direction. So as the diode is connected to the negative terminal of solar panel, so it will not allow the current to flow from battery to the solar panel. It will allow only from solar panel to battery. So it will protect the solar panel from reverse current from battery to the solar panel. So now let's build our own solar lamp. Now we have the components required: multimeter, soldering material, stripper. We need two rechargeable lithium-ion batteries, or you can take one battery as well, 3.7 volt. We need a transistor, NPN BC547 transistor. We need 10 kilo ohm resistor. We need NPN transistor BC547, a diode, LED switch, and couple of wires or cables. Now this is a solar panel, 60 by 55 mm, 6 volt and 100 milliampere capacity. We are going to put some solder material on positive and negative terminal of the panel. Now we are going to take the 100 kilo ohm resistor and connect it to the negative terminal of panel. Now take the diode, make sure that you are, so it is 10 kilo ohm. I said it 100 kilo ohm, but it's 10 k. We are going to put the diode properly, white line of the diode towards the negative terminal of solar panel. Now let's turn the diode. Now take the transistor. Now I'm going to spread the terminals of transistor. That is the outer two terminals, not the middle one. I'm going to put some metal on the diode and resistor, also on the transistor terminals. We are going to put some metal. Now connect the emitter end of transistor, that is the rightmost terminal. When you are facing that flat surface of transistor towards you, you connect that emitter end to the diode's terminal. After that, cut some extra length of resistor and connect that resistor to the middle terminal of transistor, that is base. So resistor to base connection. Now apply some metal so that these two terminals are connected properly. Now take two cables, cut them apart and stripe the both ends of these two cables. We are going to use these cables to connect to the solar panel. So twist the metal part, put that into the flux and apply metal on these wires on both the ends. Now let's connect that yellow wire onto the leftmost terminal, that is collector terminal of transistor. We have connected that wire. Now take the second wire, strip both ends and again apply flux and also metal onto this green wire. So let's connect this wire to the positive terminal of solar panel. After that, take two more cables, remove them and do the same thing. Strip them, both these wires on both of the ends and apply flux and solder metal on both the ends of both of these wires, black and red. So same process. Why it is important to apply the metal onto the cables is because it is easy to solder them later. So we have applied metal on both the ends of both of these wires. So now what we are going to do is we are going to connect the red wire to the positive terminal of solar panel along with that green wire, and connect the black wire above the diode, that is on the opposite side of that white line, or you can say towards the transistor end. Do not connect it onto the white line. Now take a battery holder. Again, apply metal on both the wires of the battery holder. Take LED, put that onto the PCB, connect LED onto the PCB. Let's check it is working. Now let's assemble the lamp in 3D printed casing. So what you can do is, we have given a QR code. We have 3D printed the box and this LED holder on 3D printer. You can use that QR code to download the file. What we are going to need is, we are going to need a long nose plier, then tweezer, some files to clean the support and other extra material. Use PPE, remove the support from that LED holder through using the long nose plier. Cut the extra fin material alongside the lines using a paper cutter. And same thing you can do with the box, this green box. You can use paper cutter to remove the extra edges and supports. You can remove the supports as well, which are not needed. These are going to be all the supports. Along the edges, there are going to be slots to assemble the yellow LED holder. Okay. Put the button through that slot. This is how it will look like. Now insert all those wires of that solar panel through that slot. Insert all those components and wires carefully through that slot on the top of that box. Make sure that you don't short circuit. Once inside, you can spread all those components. Now we are going to solder that red wire on one of the terminals of switch, and the other terminal of switch we are going to connect it to the red wire of the battery holder. Now let's connect black wire of battery holder to the black wire of our solar panel, and let's insulate that with the tape. Now let's check the LED. Once you switch on the button on and off, the LED will work. Now let's solder those wires on the LED. Apply hot glue onto the LED holder. Put that LED. Let's check whether it is at center. Once you check it, only then you apply the glue. We can also add heat sink. Let's check with it. Heat sink is used to absorb the heat. Now use the double-sided tape. Put them below the battery holder, and remove the covering and put the battery holder inside the green box. After that, put the the yellow part, that is the LED holder, to the box. Let's check. Once you switch on the button, LED will start. Apply the double-sided tape also below the solar panel. So the panel will sit firmly onto the box. Now she is reading in the light and the power cuts off. How will she read it? Oh, the solar desk lamp is handy so that she can use it for further reading. So in today's session, we learned about resistor, transistor, diode, and their function, and how they are functioning into the circuit of solar operated desk lamp. So if you have any questions, post them on the YouTube channel. And thank you very much for watching this session. I'm sure that you will learn more about these components. You will build your solar lamp and enjoy building this project. Thank you. Yeah.
Thank you, Kishore, for your presentation on simple components, electronic components, resistors, diode, and transistors. సో చూసారు కదా పిల్లలు, ఈ కాంపోనెంట్స్ యూజ్ చేసి ఎలా ల్యాంప్ తయారు చేయాలో. సో మీరు కూడా మీ స్కూల్స్లలో ఇది యూజ్ చేసి మీరు కూడా తయారు చేస్తారని ఆశిస్తున్నాను. ఇంకా ఏమైనా మీకు సందేహాలు ఉంటే ఇది యూట్యూబ్ వీడియో కూడా ఉంటుంది. ఆ యూట్యూబ్ వీడియో చూసుకొని బాగా నేర్చుకొని ఇవన్నీ కూడా చేస్తారని ఆశిస్తున్నాను. సో థ్యాంక్ యూ వెరీ మచ్ కిషోర్ గారు మరియు ఇస్మాయిల్ సార్ ఫ్రమ్ దీక్ష ప్లాట్ఫామ్. అందరికీ థ్యాంక్ యూ వెరీ మచ్.
I just have one more point. In case they don't have the rechargeable battery and solar panel into ATL inventory, they can buy from the operational expenses, which will not cost more than 100 rupees put together. Thank you.
Okay. Bye bye, children.
Bye.